So in this video we're looking at 2015 paper 2 question 9 Leaving Cert higher level maths, and it's an SEC paper. Okay, so Joan is playing golf. She's 150 meters from the center of a circular green of diameter 30 meters. The diagram shows the range of directions in which Joan can hit the ball so that it could land on the green. Find alpha, the measure of the angle of this range of directions. Give your answer in degrees, correct to one decimal place. So with the solution here, we know that this distance is 15. The reason we know that is because it's a radius. If the diameter is 30, the radius is 15. So this is also 15, and it says its radius is perpendicular. Now that's really useful as well. If I know that's 15, and I know this distance here is 150, bring that across, 150, I can find, by knowing the opposite and the hypotenuse here, remember it's opposite the right angle, so this must be the hypotenuse, I could find this angle theta. And theta is going to, or 2 times theta would be alpha. So find theta by going opposite over hypotenuse. And 15 divided by 150 is 1/10. So I'm doing sine inverse of that, and I'm getting 5.739 degrees. Double that to get 11.5 degrees. Really nice little start. Next part. At the next hole, Joan, at tee, attempts to hit the ball in the direction of the hole. Her shot is off target and the ball lands at A. A distance of 190 meters from tee. So we know this length here is 190 meters. The angle ATH is equal to 18 degrees and TH is 385 meters. Find AH, that's this length here. So we want to find the length. Is it a right angle triangle? No, it's not a right angle triangle. What formulas can we use? Can we use the area formula? No. Can we use the sine rule? Okay, well, let's check. Can we use the sine rule? Do you know a side and its opposite angle? No, not there. Side and its opposite angle? No, not there. Do you know a side and its opposite angle? No, not there. That leaves us with only one option, which is the cosine rule. Most importantly, when filling in the cosine rule, make sure that the side that we're looking for is opposite the angle that we know. So we know this angle here is 18. Okay, fill everything then that we know in. It doesn't matter if I use this as B or this as B. And then the other as C. That won't make a difference. Just make sure that this side that I'm looking for is opposite the angle that I know. The cos 18 here, I don't want to find a squared, I want to find just a on its own. So I've taken the square root of this whole right hand side. You could take your time and go and work this right hand side out before typing it all into your calculator inside a square root. And make sure we answer it correctly. We're looking for AH, which is equal to 213 meters. Next part of the question then. Okay, so not so much a trigonometry question, more a little functions question. At another hole, where the ground is not level, Joan hits the ball from K as shown. The ball lands at B. The height of the ball in meters above the horizontal line OB is given by. So this function is height, where T is the time in seconds after the ball is struck and H is the height of the ball. So find the height of K. So find this height here. Well, when is it at K? It is at K at time is equals to 0. So if I got, or sub in T equals 0, I should be able to find H. Okay, so sub in T is equal to 0, and you get H on its own. So I know this height here is now 8. The next part is a distance, speed, time question. The horizontal speed of the ball over the straight distance OB is a constant at 38 meters per second. Find the angle of elevation of K from B, correct to the nearest degree. So I'm looking for this angle here, theta. And it says the horizontal movement. So how quickly it's moving this way is 38 meters per second. So if it took 1 second to land, it would only have traveled horizontally 38 meters. If it takes 2 seconds to land, it would take double 38. If it takes 3 seconds to land, it would take triple. 38. But how long does it take to land? Well, when does it land? What are the conditions of it landing? It lands when the height is 0. Remember, its height was 8 to begin with. It lands when its height is 0. So it lands, at what time will it hit the ground? It will hit the ground when h is equal to 0. So subbing in 0 for h, and we get a quadratic equation. Solving the quadratic equation, we get two answers. One is -1/3, and the other is 4/3. We don't care about the -1/3 situation. -1/3 was all the way back here. We don't care about that. Negative time isn't anything we're worrying about here. So it takes 4 seconds to land. So how far has it traveled horizontally? Remember, the 38 was just its horizontal speed. So it's 38 times 4 to see how far it has traveled horizontally. We now know how far it's traveled horizontally and how far it has traveled vertically. With that information, and knowing this is a right angle, we can use tan to find the angle of elevation here, the 3 degrees. At a later hole, Jones' first shot lands at the point G on the ground. On ground that is sloping downwards as shown, a vertical tree, CE 25 meters high, stands between G and the hole. The distance GC from the ball to the bottom of the tree is also 25 meters. The angle of elevation at G to the top of the tree E is theta, where theta is equal to tan inverse a half. If you're ever given theta like that, I would highly recommend getting tan of theta. So if you're given tan inverse, just write it as the tan of theta is equal to a half. The height at the top of the tree above the horizontal GD is h meters, and GD is equal to d meters. So this distance they've given us as a variable d. Write d and CD in terms of h. Okay, so first of all, consider this. So I want d equals, write d in terms of h. I want d equals something with a h in it. Something with a h. Well, this is a right angle triangle. What do I know about it? I know this is d, this is h, so I know tan theta is equal to h over d. But tan theta, I'll move this up, is also equal to a half. Remember, tan theta is equal to a half. From there. So now multiply both sides by d, and then multiply both sides by h to get d on its own. So that's the first part of the question answered. Gotten d in terms of h. Now let's consider getting CD in terms of h. So CD is this length here. What do I know about this length here? Well, it's 25 minus h. It's not the full height of the tree. It's minus this little bit here. I know it's a right angle triangle, and I know this is d. And I know the hypotenuse is 25. So I could use Pythagoras Theorem to find, that's the next part of the question. CD is all I was asking for. CD in terms of h. That's this length here, this red blue length here. That's CD. So we've gotten 25 minus h. Perfect. It's the next part of the question, and I think, hence or otherwise, find h. Well, we utilize this triangle. We know this d in terms of h. We know this length in terms of h, and we know this is 25. So the problem here is there's two variables, d and h. So one equation and two unknowns, you're not able to solve that. One equation and two unknowns can't solve that, but how do you get around that? Well, we know what d is in terms of h. Sub that in. Now we have one equation with one unknown. That's our h. Multiply it out. 2h squared is 4h squared. 25 by 25 is 65. 25 by minus h is minus 25h. Minus h by 25 is minus 25h. That gives us our minus 50h. Minus h by minus h is h squared. 25 by 25 is 625. Subtract 65 from both sides. Divide by 5 would give us h squared minus 10h is equal to 0. Now factorize out h. Now factorize out h, what do we get? So remember, a lot of people will try and divide by h. Don't divide by h. Don't divide by h. What's the power? The power is 2. Okay, so that means we want two answers. Okay, so either this number is 0 or this number is 0. Okay, now I know h is equal to 0 is not a reasonable answer, so don't exit out, don't include it, and then your final answer will be 10. But do not divide by h. That's something we shouldn't do in this case. Okay, looking at the marks going for the question, there's 10 marks for the first one. Okay, just using SOHCAHTOA, lovely question. 10 marks for the next one using the cosine rule, again lovely, that's 20 marks. 25 marks then achieved by just subbing in 0 for t. That brings us up to 35 marks for actually a good bit of work. 10 marks is probably very fair for that question. It is tricky enough to first of all solve the quadratic, then use distance is equal to speed times time, and then use tan. So there are quite a few steps to that question. 5 marks for the last two questions then. Probably not very well answered, even though they're not actually that difficult. I think probably the problem with it is there's a lot of talking there, and a lot of useless information. When you just consider the diagram, you're probably fine. And then the last question, 5 marks going for that using Pythagoras. Okay. Hopefully you find the video useful.